Hello and welcome to another one of these ADD videos. Today we're going to look at the concept of halogenation. Halogenation is the process by which we can take an alkane or an alkene and get what's called an alkyl halide. Basically all you're doing is you're tagging on a halogen somewhere on that alkane or alkene. Here we have a hydrocarbon, an alkane, basically nothing but carbons and hydrogens, and through a series of steps when we add a diatomic halogen, if you remember halogens in general exist in a diatomic state. That's the diatomic state right there. And when most nonmetals exist freely in nature, they exist bonded to themselves in this state. So if we look at an alkene, there's a process called allylic bromination, for instance, that takes your bromine and sticks it right here at the allylic position. We'll talk about that later. It'll have its own video. But let's look at the basic steps of this process of halogenation, creating an alkyl halide. And there are going to be three major reaction types that you will observe. The first one's initiation. We have to get it started. So to get it started, we undergo what is called a homolytic cleavage. Okay? And that's basically when we take this diatomically bonded halogen, it's bonded to itself, and we break the bond in half, leaving one electron with each halogen. Okay, so we'll call this a halide free radical. But if you remember the natural state of a halogen, there are 6 valence electrons, and then there's this bonding electron that it has. This is the natural valence state. So sometimes you might see it referred to as the bromine atom or the chlorine atom. Okay, so it is in essence a free radical by having an unpaired electron, but that is its normal valence shell. So there's also a heterolytic cleavage. Do I have that on this one? No, that's a different slide, I believe. Heterolytic cleavage would have taken, one of them would have taken both electrons, sorry about that, creating a cation, and the other one would have, or an anion, sorry, and the other one wouldn't have gotten any electrons, and that's referred to as heterolytic. So you create a cation with no electrons from that bond that they were sharing, and one with both of the electrons. Okay. Here, when we're doing the initiation step, we require some sort of energy. Like for bromination, it's going to be heat. For chlorination, it's going to be blue light. All right. So propagation. So propagation creates free radicals and it eliminates or consumes them. On initiation, we just created the free radical from the diatomic halogen. Here, what happens is that free radical that you got from splitting the halogen bonded to itself can get an alkane. I just chose methane randomly, and it can abstract one of the hydrogens and leave an electron behind. So here's one free radical that's consumed. It goes right here, and the other one that is formed. Facebook message, sorry. So this one is formed, this one's consumed. And the other one is when this free radical encounters one of the diatomic halogens. So you can see how this is kind of a snowball effect. One creates the other, which then finds another one of these, which then creates another one of those, which then comes to contact with one of those. So one photon of light for chlorination, for instance, can initiate a bunch of these reactions. It's a snowball effect. All right? So propagation, you consume and create free radicals. Termination, you just consume the free radicals. There are no more any left. The desired one is the one that is the alkyl halide. If you remember, we did create an alkyl halide on this step. Sorry about that. And the reason it's not a termination step is because we formed this free radical. We cannot form any free radicals in a termination step. So here, both the free radicals form the bond, right? Here are the two free radical electrons, and there's bonding the carbon and the halogen, and you get the alkyl halide. Then there are the unwanted ones, the termination reactions that consist of either the free radicals bonding to the wall of the container, so the free radical, the halogen, can bond to the container wall, or the methyl free radical, or the two methyl free radicals can bond to each other, recreating diatomic halogen, or the two methyl free radicals can form ethane, all unwanted side products for the desired reaction that we have here. Okay? So that is halogenation in a nutshell, the concept behind each reaction. Become familiar with them. You'll see there will be differences among the non-selective fluorination or the slightly more selective chlorination, which is an exothermic reaction, or the endothermic bromination, which is a lot more selective due to differences in activation energy. We'll talk about kinetics, thermodynamics. So there will even be some mathematics when we're talking about the selectivity of the different hydrogens that get replaced. So make sure you understand these basic concepts well. Check out the example videos for each one of those topics I just listed. There will probably be concept videos as well for them. And there will be an individual video for chlorination and bromination reactions and their specific selectivity, thermodynamics, and kinetics. I hope I've removed any doubts that you might have over the basic concept. Thank you and have a nice day.